Hi everyone, welcome to this lecture on Chapter 8. So with Chapter 8, we begin a new unit. So we start into what I'm calling Unit 3. And in Unit 3, we're going to be talking about our micronutrients. So in Unit 2, we learned about the macronutrients, carbohydrates, fats, and proteins. Remember, those are these larger molecules that provide calories, whereas these micronutrients, we'll talk pretty exclusively about vitamins and minerals, and we'll also visit this concept of phytonutrients. So the micronutrients, specifically vitamins and minerals, do not provide calories to the body, but they do support overall body functioning in a variety of different ways. So Chapter 8 and Chapter 9 and 10 and 11 go over the various micronutrients and the seemingly innumerable functions and roles that they play in supporting the health of our bodies and the overall functioning and regulation of our bodies. So whereas I tried to encourage a lot of just understanding in Unit 2, in Unit 3, there is quite a lot of memorization, I think, that takes place here. So not so much understanding, but just really starting to identify the various vitamins and minerals, understanding, learning, and trying to remember their jobs, basically, in the body, as well as some food sources in which we might find those nutrients. So another thing I'll say about Unit 3 is that we're going to, or I'm going to, well, and the textbook divvies up this information based on the body system. So rather than just going through and saying, okay, here's your minerals A through Z, here's your vitamins A through Z, just know them and remember them, we are going to break them up by body system. So in Chapter 8, we're talking about the system of metabolism. So kind of a nice place, because in Chapter 7, we talked about metabolism a lot. And we hopefully came to understand what metabolism is. Again, that combination, that sum of all chemical reactions in the body. And hopefully you'll remember we talked about various types of chemical reactions. We talked about phosphorylation and dephosphorylation. We talked about reduction and oxidation. We talked about hydrolysis and dehydration synthesis. So some of what we'll look at here, well, sorry, let me also say we talked about glycolysis and lipolysis. We talked about beta oxidation. We talked about how little fatty acids need to be transported to the liver, to the muscle tissue to actually be fully metabolized or broken down to release energy. And we talked about the Krebs cycle, and we talked about the electron transport chain. So what we're going to see here in this chapter on nutrients, specifically micronutrients that support metabolism, we're going to see where several different vitamins and minerals fit in to those different pathways and support those different processes of metabolism. So kind of a wordy introduction there, but let me also say, I don't have an objectives page, I guess, really for any of these lectures. So jot this down. What I do want you to get out of Unit 2 is certainly an identification of vitamins and minerals. The fundamental thing I want you to be able to do is differentiate between a vitamin and a mineral. And as we talk about these different micronutrients, because we're going to talk about probably a couple dozen, I want you to know whether the nutrient is a vitamin or a mineral. And then I want you to know what the basic functions of that vitamin or mineral are in the body, specifically which body system. And sometimes we'll see body systems. So which body system or systems that micronutrient supports. I want you to also be able to identify if there are diseases or disorders associated with undernutrition of that micronutrient. So in the case where somebody isn't consuming enough of that nutrient, I want you to be able to identify the symptoms are and if the symptoms actually have a name. And then also identify if there's toxicity, like if the person consumes too much of the micronutrient. Okie doke. And then lastly would be food sources. So be able to identify some food sources of the micronutrient. Alrighty, so as always, email me with any questions, but let's dive in here. Just a review of vitamins and minerals. Remember, these are our micronutrients, right? Micro as opposed to the macronutrients that we've been talking about so far. So micronutrients. By definition, micronutrients do not provide calories, and therefore they do not provide energy directly. What we'll see is that a lot of them support metabolism, so they support the process of harnessing energy from our macronutrients, which is what's written here. And then we're going to see a lot of them function as coenzymes. So remember that coenzymes are these molecules, oftentimes vitamins, that support the function of enzymes. Right? So remember you saw that in chapter 7, we saw that cool diagram, in which the enzyme didn't work with its substrate until it had the coenzyme bound to it. So the enzyme only became active when the coenzyme bound to it. And we're going to see, so specifically in this lecture, chapter 8, we're going to see that B vitamins in particular function as coenzymes to support the process of harnessing energy from our macronutrients. So here's a little sneak peek, a little overview. You might remember some of these coenzymes. Some of these might look familiar to you, like CoA. Remember when we talked about acetyl-CoA as that molecule that starts the Krebs cycle? We saw a form of FAD, right? We saw FAD being converted to FADH2. And we saw NAD being converted to NADH in those redox reactions. We didn't really look at these others, although had we kind of zoomed in, were this a chemistry class or like an organic chemistry class, we would have even looked at all of those various steps of the Krebs cycle or the tricarboxylic acid cycle, and we would have seen virtually all of these coenzymes playing a role throughout that process of the Krebs cycle and throughout the larger process of macronutrient metabolism. So then up top, what you'll see is that these coenzymes are derived from vitamins. And we're going to go through each one of these. But thiamine is vitamin B1, riboflavin is B2, niacin is B3, vitamin B6 we will talk about, folate we'll talk about, pantothenic acid is B5, also sometimes called. We'll talk about biotin, which is sort of an honorary member of the B vitamin family. And we'll talk about vitamin B12. We're going to go through each and every one of these. And then again, down here is kind of a cool summary again of where each one of these different micronutrients plays into either and protein metabolism, carb metabolism, and fat metabolism. Okay, just a little review about coenzyme. Remember, it's that molecule that joins with the enzyme to activate it. And again, we're going to see these B vitamins, thiamine B1, riboflavin B2, niacin B3. We're going to see vitamin B6 and pantothenic acid and biotin all work as coenzymes to function in energy metabolism. And then we're going to see folate and B12 function in specifically red blood cell synthesis, and then also support cellular regeneration, like during periods of growth or recovering from an illness, trauma, or injury. So again, if you toggle back here, with the exception of folate, they do support these pathways too, but you'll see that folate really shows up here in protein metabolism, same with B12. B12 does show up in about all of these, but then you'll notice that the rest of these micronutrients really fully support all of the macronutrient metabolism. So all of the B vitamins But then knowing, this is important to know that folate and B12 specifically, that they also support red blood cell synthesis in addition to energy metabolism. Yeah, I guess I won't spend any time here, but you can just see again the full process starting from glycolysis and ending with the tricarboxylic acid cycle. You can see all these ways in which these different coenzymes, which are B vitamin derivatives, fit in and support this process. So remember I said, if we were to zoom in on the TCA cycle, we would see that we talked about NAD and FAD, but we would see that a lot more of these B vitamin coenzyme derivatives would show up and help out. So you can see virtually all of them do, especially if we start at the top from glycolysis. So this is just a helpful overview page if you want to use this to review. I will not ask you to remember the RDA for the different micronutrients because, let's face it, I don't memorize this stuff. These tables are always available to you. They're always available online. They're always available in your textbook if you purchased it and save it for life. You'll always be able to reference it. But remember who writes the dietary reference intake values, right? Hopefully you remember this term, RDA. Hopefully you remember that this is part of the dietary reference intake values, or the DRIs. If you maybe remember who writes those, that's the National Academies of Sciences, formerly known as the Institute of Medicine. So you can always go to the the National Academy of Sciences website and look up the DRI charts if you don't memorize these. So this information is always freely available to the public. So anyways, you can take a look though, just to kind of start to introduce yourself and become familiar. You'll see that the RDA is generally listed for 19 years or older. Males and females, yeah, I didn't go back through and change all of these, but anyway, men, woman, male, female, you'll see that the requirements are usually a little higher for males. Sometimes they are the same. And then you'll also see in some cases there's an RDA for older adults, basically, so 51 years or older. And typically you'll see that the requirement actually goes up, and that's just due to like decreasing efficiency in metabolism and absorption. And then here's page 2. Yeah. I thought it would be listed here, but oh, that's so funny. Look, when you zoom in, it's milligram in like microscopic font. It's not listed on this chart, I guess. Okay, with some of these, especially like folate, in some cases there may be an increased recommendation during pregnancy. I thought it was listed on these charts, but I'm not seeing it. So again, you can reference your textbook and reference the National Academy's website. But again, I'm not expecting you to remember these exact RDA numbers. I do expect you to know what RDA means. So review that from chapter 1 if you need to. But again, this is basically the recommended daily intake of these nutrients to support overall health for otherwise healthy individuals, or at least meeting the needs of at least 97 to 98% of the population. All right, here we go. It begins. So we're going to go through, I think we do have close to a dozen micronutrients to talk about just in chapter 8 alone. So we'll start with thiamine, which is also known as vitamin B1. And I do want you to know that too. I want you, if I say B1, I want you to know that I'm talking about thiamine. So thiamine is part of the coenzyme, or with thiamine we can make the coenzyme thiamine diphosphate, which is required for the metabolism of glucose and some of the amino acids. Therefore, thiamine supports carbohydrate and protein metabolism. We're also going to see that thiamine supports, in addition to metabolism, supports DNA and RNA synthesis, and as well as some neurotransmitter synthesis. Thiamine we find in not all foods really, but pork, like pig meat, can actually be a source of B1. Beans can be a source of B1. Whole grains can be a good source of B1. You might remember when we talked about grains and grain processing in Unit 1, I indicated that the bran and the germ and the intact whole grain is a really rich source of different B vitamins. But when we process the grain into a flour, and especially into a white flour, we lose a lot of the B vitamins. So eating intact whole grains are really important to provide all the different B vitamins to the body. And then sunflower seeds can also be a source of thiamine. So here's our first example of a disorder associated with thiamine deficiency. So if someone, and it has a name, so I do want you to know the name beriberi, and I do want you to know that this is what comes about when a person does not have enough thiamine in their diet. So beriberi is kind of defined by nerve damage and muscle wasting. Again, this would happen over really months of inadequate B1 intake. There's a secondary thiamine deficiency disorder called Wernicke-Korsakov syndrome. You'll see similar symptoms: muscle weakness, tremors, confusion, and memory impairment. But this is a really an alcohol-related thiamine deficiency. So it occurs when there's excessive alcohol intake over a prolonged period of time, and it just leads to a deficiency of B1, because B1 can be used to support alcohol metabolism. And then there's also usually a secondary aspect of Wernicke-Korsakov here, which is not exclusively that there's excessive alcohol intake, but that with excessive alcohol intake, the person often isn't eating a well-balanced diet. So there's sort of a twofold cause. There's too much alcohol coming in, and there's not enough healthy food coming in that would supply an adequate amount of B1 to manage all that alcohol metabolism. I'm always going to show you a picture of the chemical structure of these nutrients, and I don't need you to remember them. I'm a very visual learner, and I like chemistry, so I just sort of show these. Your book has these laid out, and I think it can enhance our understanding of these nutrients, but I certainly will not expect you to remember the chemical structure. But anyway, here's thiamine up top. So you can see it has also actually kind of an amine backbone, a ringed structure. It has an NH2 group. There are other nitrogen compounds in the ring. And then you'll see thiamine, it has this amine group attached to a root compound, which we call thiazole. And then down here is showing thiamine diphosphate. So again, you can see here is the basic thiamine backbone. And then it's thiamine diphosphate, right? So di meaning two, phosphate meaning phosphate groups. So you have these two phosphate groups attached to the thiamine backbone. And then again, just going back here, I guess I'll go all the way back. Right, thiamine diphosphate is abbreviated TDP. Pretty straightforward, right? Thiamine diphosphate. And then food sources. So again, just kind of a visual look. So again, you'll see whole grains, and this is saying, it's showing you cereal. But remember, the intact whole grain is going to be your true best source of B vitamins. I mean, relative to the processed grain derivative like cereal. All these charts, we have one for each of the micronutrients we'll talk about here. They're all going to show you where the RDA is. For males and for females. So you'll see that 3/4 cup of a cereal, which might have been enriched with thiamine, meaning added back in after the processing, is actually going to exceed the RDA for thiamine for males and females. So that's cool. If you don't eat cereal, you could see spaghetti, 1 cup of spaghetti, or white rice. These are both processed grain foods. They're going to get you part of the way there. I wish this had an actual whole grain, but again, that would be a nice, simple, even probably just a half cup of an intact whole grain would still meet the RDA for males and females for one day. Alrighty, number 2, riboflavin. So riboflavin is vitamin B2. Riboflavin is involved in our redox reactions. Remember, redox is the abbreviation for, or the shorthand way of saying oxidation reduction. So riboflavin, we're going to see present in support of the electron transport chain. Remember, I said that the electron transport chain is basically this process of just transferring electrons, and in doing so, basically powering the process of making ATP. B2 is also part of a coenzyme, system, which we can call glutathione peroxidase. And we'll talk about this later on in Unit 3, but glutathione peroxidase is part of our antioxidant system. You might remember when we talked about lipids and we talked about plaque buildup in the arteries or in the blood vessels, we talked about the low density lipoproteins becoming oxidized. So oxidation, same thing here. Oxidation is loss, so it's loss of an electron. But oxidation is also actually akin to like spoiling or rusting. Like if you bite into an apple and you leave the apple then with a bite out of it on the countertop, the outside will start to turn brown, or the skin will start to turn, the flesh that's exposed to the air will start to turn brown, and it will even get like a funny coating on it over the course of the day. That's actually oxidation happening. So whatever little apple cells are exposed to the air at that point, the oxygen in the air is starting to cause some damage to those cells. So we have oxidative damage occurring in our bodies all the time. It's sort of a natural course of living, but we also have systems to counteract oxidation. So we call those systems antioxidant systems, and we're going to spend a whole chapter talking about antioxidants later on. So glutathione peroxidase is one type of antioxidant enzyme system that can support the counteraction of oxidative damage throughout the body. Food sources for B2 for riboflavin, milk or dairy products, also eggs, meat, broccoli, again, whole grains. So we're going to see whole grains are going to be a good source of many of our B vitamins. Of course, all of our vitamins are light sensitive, remember? We said that light, heat, air, meaning oxygen, as well as an acidic environment can all change the structure of these vitamins, whereas minerals are already in their simplest form, so they can't really be destroyed or altered by any sort of environmental factors. So this is why any sort of B vitamin supplement is going to come in an opaque container so that light can't get into it. This is also why milks, which are typically fortified with B2, also come in an opaque container so that light can't get in and destroy the vitamins. Again, there is a deficiency I want you to be aware of for B2. So we call that A riboflavinosis. Again, hopefully if you see this word on a test or a quiz, you can see that it says riboflavin right here. Osis, is going to be some sort of disorder associated with lacking the riboflavin, as is indicated by the A, right? So riboflavin, A riboflavinosis is riboflavin deficiency, and that's characterized typically by a sore throat as well as swollen mucous membranes. Again, here's your chemical representation of riboflavin, also kind of a ringed structure. There is no amine compound though, but there are some nitrogens. And then of course, these long carbon chains. And then down here, I feel like maybe I cut it off. Down here, you're going to see some of the coenzyme derivatives of riboflavin. So we're going to see, this stands for Flavin Mononucleotide. I already forget what FAD stands for. You can read it in your book. But you'll see that we start with the riboflavin backbone here. And then with flavin mononucleotide, we've added one phosphate group. And then the FAD adds, pyrophosphate groups. And the FAD adds 2 pyrophosphate groups as well as this AMP side chain. So again, you don't need to remember any of this, but just showing you that these 2 coenzymes, FMN and FAD, are derived from the riboflavin, and that's why they start with F, is to represent the flavin aspect of the riboflavin name. Food sources, again, whole grains are going to be great. You'll see, again, a 3/4 cup of a cereal is going to exceed the RDA for riboflavin for the day. This is instant oatmeal, 1 packet, maybe not quite halfway there for females. Also found in spinach, mushrooms, eggs, as we said, dairy products. So for a lot of folks, 1 serving of whole grain can support B vitamin intake. Otherwise, this is why eating a variety of foods is also important, because we're going to get a little bit of a lot of different nutrients from most of our foods. So if we eat a nice variety of different foods, we should be getting a pretty good amount of all of the different micronutrients that we need. All right, vitamin B3 is niacin. So niacin also has a couple forms, nicotinic acid and nicotinamide. Niacin also supports redox reactions, meaning metabolism of all 3 of our macronutrients. We can actually make niacin, a little bit of niacin from the amino acid tryptophan. Otherwise, again, we're going to find whole grains, meat, fish, and poultry as food sources. And then again, pellagra. So I want you to know beriberi, A. riboflavinosis, and pellagra. Pellagra is niacin deficiency, and pellagra is characterized by diarrhea, dermatitis, so a skin inflammation, dementia, and death, right? So death in severe cases, right? Niacin deficiency doesn't necessarily lead to death, but if it goes on for too long, this can be the progression of niacin deficiency symptoms. So we kind of call that the 4 Ds. We can also see some toxicity from niacin supplementation, and we'll see this. Not all of these micronutrients will cause a toxicity or a toxic effect, especially the vitamins, because they are water soluble. If we consume too much of them, there might be like a mild, we call it a toxic effect, but it doesn't mean like deadly effect. So for example, like niacin, if somebody takes too much niacin in supplement form, they might have like a redness or a flushing of the skin for a couple of hours until their body can quite literally flush out and pee out in the urine the excess niacin. So a lot of times we'll see that with water-soluble vitamins, that the body can get rid of the excess, but it'll just take a couple of hours. We'll also see that toxicity typically only happens due to supplementation, meaning taking a concentrated dose of the micronutrient in, pill or tablet form. It would be very, very, very difficult to eat too much of any micronutrient, again, because they occur in our foods in such relatively small amounts. Food sources, again, you're going to see whole grains, again, some fish, yep, and then could be beef and chicken as well. All right, vitamin B6, which is sometimes called pyridoxine, but you'll see there's actually 3 different forms of vitamin B6 that are all quite common. So oftentimes vitamin B6, we just call it B6. So vitamin B6 has a lot of roles, again, supporting metabolism, supporting gluconeogenesis. So again, that's the process of making glucose from non-carbohydrate substance, namely proteins and fats. B6 also supports heme synthesis. So heme being that important component of hemoglobin, which is that oxygen-carrying protein in your red blood cells. Also supports neurotransmitter production, immune health. B6 can also metabolize niacin, folate, and carnitine. And then here's an important one to note with B6, at least for our class. So B6 in conjunction with B12 and folate can actually help reduce cardiovascular disease because all three of these can help to metabolize this molecule called homocysteine. And homocysteine can be a marker for cardiovascular disease risk. So oftentimes if people are low in B12, B6, and or folate, their homocysteine levels might become elevated, and that puts them at a risk for cardiovascular disease, a higher risk. So here are the what we call isomers, or the slight variants of this B6 chemical structure. So pyridoxine is what we had written here, right? Pyridoxine. But again, there are three very similar shapes. So another B6 isomer is pyridoxal, and then the third is pyridoxamine. Again, you don't really need to know all of these, but you can start to associate that P with vitamin B6. So PNP, PLP, and PMP, the different forms of B6. And then where do we find B6? Again, pretty abundant in meat, fish, and poultry, as well as whole grains. So again, similar theme here from B1, 2, 3, and now B6. Also some of our starchier vegetables. So things like sweet potatoes, winter squashes, they can also supply a little bit of B6. We can again see toxicity from over-supplementation with B6, and this would lead to nerve damage and actual lesions of the skin. We can also see issues with deficiency of B6. And really, in any case, we'll see issues of deficiency with any micronutrient. So because of the various functions of B6 in the body, we're going to see that a deficiency of B6 will affect various systems, our skin, our blood, our nervous system. We can also wind up with anemia if we have a B6 deficiency. So remember anemia, well, we haven't talked about anemia yet, so I shouldn't say remember. But anemia basically means poorly shaped or misshapen red blood cells. And so here, right, we said that B6 helps with heme synthesis, so heme being a component of our red blood cells. We will talk a little bit more about this coming up. So this is a good one to remember, that B6 deficiency can be a cause of anemia. Symptoms of B6 deficiency, depression and confusion, as well as convulsions. So here's homocysteine metabolisms. You'll see B6, B12, and folate all support metabolizing, or basically breaking down, homocysteine. So B6 can help convert homocysteine to cysteine, which is one of our non-essential amino acids. And then folate and B12 can convert homocysteine to methionine, another non-essential amino acid. So with any deficiency of any of these nutrients, we will likely see a buildup of homocysteine in the blood, which is a risk factor for cardiovascular disease. So garbanzo beans, kind of new on the scene here, great source of vitamin B6. 1 cup is going to greatly exceed the RDA for males and females. Again, whole grains are going to be a great source as well. As I said, potato and other starchy vegetables are going to provide some. And you'll see meat, fish, and poultry are going to provide a little bit as well. Okie dokie, folate. Folate is sometimes called B9. Hope I'm not saying that wrong. I think it's B9. I don't even remember, actually. I think so. You don't need to remember that. Let's just go with folate. Folate is really critical. Again, this is one where intake prior to pregnancy and then during pregnancy is really critical. So folate, in addition to supporting metabolism of our macronutrients, also supports embryo development. So if there is a deficiency during pregnancy, folate deficiency during pregnancy leads to neural tube defects in the infant and can lead to anemia as well as heart disease in the pregnant person and potentially in the infant later on. What did I skip up here? Enzymes. So folate supports various enzymes that support metabolism as well as DNA synthesis and cell differentiation. Again, synthesis of new cells and repairing damaged cells. Food sources of folate. So this is important. This is starting to be a variance from those first 4 B vitamins. Green leafy vegetables are really one of the best sources of folate. We also see that a lot of foods are fortified, meaning folate is added to foods where it doesn't naturally occur. And then so a lot of cereals and bread products and even milk products are fortified. But green leafy vegetables is your best naturally occurring source of folate. And then we also have some other sort of random foods: liver, lentils, asparagus, and oatmeal. So here we've got kind of 2 things happening here. We have folic acid as, 2 forms of folic acid. So we have this monoglutamate form and this polyglutamate form. Again, glutamate just being this basically like side chain that might be attached to this folic acid backbone. So monoglutamate meaning 1 glutamate side chain, polyglutamate meaning many. In this case, it's 4 glutamate side chains. So polyglutamate, folate in its polyglutamate form is what we typically find in our food. And so in order to absorb folate into our bodies, into the enterocyte, right, that little cell that lines the small intestine, we have to convert folic acid into the monoglutamate form. So that this form is often abbreviated THF, which stands for tetrahydrofolate. So you'll see tetrahydrofolate gets absorbed. So you have your folate backbone with the 1 glutamate side unit. And then in order to so then we absorb the tetrahydrofolate to the liver, but in the process we've added, so in the enterocyte we add, we add a methyl group, I guess, quite literally. So now we call this methyl, and that's spelled wrong. There's an R in there. This should just be 5-methyl tetrahydrofolate. So a methyl group gets added. It's not shown up here, but a methyl group gets added to this tetrahydrofolate, and that's what travels through the portal veins to the liver. So the liver receives this form of folate called 5-methyl tetrahydrofolate. So this is actually a really important step in terms of understanding if a person is deficient in folate. Sometimes the reason they might be deficient is because this step of being able to methylate or add this methyl group to the tetrahydrofolate compound is lacking. So that's a really important thing to look out for when folate deficiency exists. Obviously, folate deficiency could exist because the person isn't consuming enough, but it could also result from a failure to actually methylate the tetrahydrofolate. So then you'll see it's this 5-methyl tetrahydrofolate form that travels throughout the rest of the blood. And then at the various body cells, folate will be metabolized for whatever its purposes might be. So we saw on the B6 slide that B6 can help metabolize tetrahydrofolate. What we haven't seen yet, we haven't talked about B12 yet, but B12 can also metabolize tetrahydrofolate. And then B2 can also be part of the larger process of folate metabolism, depending on what the needs or uses are of the cell at that time. So what I want you to take away, I guess, from this slide, maybe a couple things. Again, most of these micronutrients actually occur in several different forms. They might be transported in one form, absorbed from the intestines in a different form, and then actually utilized in whatever body processes in yet a third form. So in this case, I just want you to remember that this process of methylating the folate is really important for absorbing it actually into our blood out of the intestinal enterocyte. Okay, so food sources. Here's spinach, the one dark green leafy veggie representative. Here's a whole grain. Again, this is a cereal. So again, this might be this is probably a fortified food. Lentils, also 1 cup, are going to get you nearly the RDA. And then some other broccoli, pinto beans, and then these are all processed green foods. So the whole, whole grains aren't necessarily a great source of folate. Processed grains that are fortified, meaning they've had folate added to them, can be a source of folate. Alrighty, and then vitamin B12. So worth knowing this name for B12, cyanocobalamin. You might also see it written as just cobalamin. And so the reason that it's called cobalamin or cyanocobalamin is because it has this cobalt element at the center of it. I'll show you on the next page. So again, B12, as we've said, supports homocysteine metabolism and supports DNA synthesis. Also essential for the nervous system. We're going to take a look at the absorption of B12 because it's also complex, just like folate. And then food sources of B12. So B12 is very unique in terms of food sources. We now know that B12 is actually made by bacteria and possibly some types of algae, but don't have a ton of information on that at this point. So these bacteria can live in the soil, and they can also live in some mammalian guts, like cows, for example. So a lot of people get their B12 from meat because there's bacteria that lives in the gut of these animals. To my knowledge, at this point, humans don't house the bacteria that make B12, but again, soil does. So theoretically, like home gardening, if you're using not a lot of like artificial chemical inputs, if you don't wash your produce too much, and you might consume actually some B12 from the soil bacteria. Then there are lots of foods these days that are fortified with B12, and your book calls nutritional yeast a quasi-supplement. I don't remember if we use nutritional yeast at all in any of the recipes this semester, but you can certainly go out and buy nutritional yeast. It's pretty abundant now at various grocery stores. Not abundant, but pretty available and at most grocery stores. And it's literally a dehydrated yeast that you can sprinkle on top of salads or pastas or really any sort of dish, a stew. And a lot of plant-based recipes these days will use nutritional yeast to make like a cheesy sauce. So that's an excellent source of B12 is nutritional yeast. Otherwise, a lot of people are supplementing with B12 these days because our food system is so hypersanitary now that most like commercial produce really doesn't have any B12 on it. That's why I said home gardening, like home vegetable gardening, could potentially be a source of B12. So deficiencies are rare. We're going to see that B12 requirements are actually relatively low. The RDA for B12 is relatively low. And again, in the United States, for the history of the US anyway, many United Statesians have been pretty heavy meat eaters. These days, we're starting to see a little bit more B12, actually, maybe I should say a lot more B12 deficiency. And that's again in part because of the hypersanitization of our food system. Many cattle or cows raised for meat are given a lot of antibiotics. Well, many of them are broad spectrum antibiotics, so they kill off lots of bacteria, including the bacteria that would produce B12. So we're finding that even meat is no longer a super rich source of B12. Furthermore, a lot of cows, the majority of cows raised for meat production are no longer raised on pasture, so they're no longer actually in soil themselves, and they're fed very sterile diets. So we're finding now that meat is no longer a rich source of B12, so even omnivores are now having to supplement with B12. And then, of course, anybody following a plant-based diet without any meat consumption, and if they don't eat nutritional yeast every day, they may also be at risk for B12 deficiency. So supplementation is certainly recommended. We're going to see that B12 can be another source. B12 deficiency can be another source of anemia. Another reason why deficiencies are over history, why deficiencies have been less common with B12 is because we can store a little bit of B12 in the liver. So about 2 to 3 milligrams, which is quite a lot when you see relative to the RDA. But again, this is about a few months supply or several months supply. So B12 deficiency is something that might creep up slowly on a person. So it's good to kind of keep an eye on. Okay, so I said that absorption of B12 is also a little bit complex. So let's take a look at that. So in the stomach, B12 in our food is often attached to a protein. So in the stomach, again, we need to have enough hydrochloric acid present, right, to detach the protein. So anybody who has any sort of gastro issue, any sort of stomach issue, if they're not producing enough hydrochloric acid, or if they're taking antacids, they're not going to be able to separate the B12 from the protein. So right there, it makes the B12 unavailable. Also, anybody who's undergone any sort of gastric bypass or stomach stapling, any sort of bariatric surgery will be at a heightened risk for B12 deficiency because their production of hydrochloric acid will be so excessively low. So anyone who's undergone bariatric surgery is on a pretty strict vitamin B12 supplement for life. Okie doke. So then also in the stomach, once B12 is separated from the dietary protein, our bodies make this other protein called R binder protein. So B12 is then bound to this binder protein, and that's what allows B12 to pass from the stomach to the small intestine. Or, I mean, it will pass from the stomach to the small intestine, but if it's bound to this protein, that makes it more bioavailable to our bodies to absorb. The stomach also creates something called intrinsic factor. We talked about that a little bit in chapter 3. So again, anybody who has any sort of stomach issue is not going to be producing intrinsic factor or not enough. So again, that's another reason why that person would be at an increased risk for B12 deficiency. So then in the small intestine, we see that the B12 separates from the binder protein and then is available to bind with intrinsic factor. And we need the intrinsic factor for the enterocyte to absorb B12. Intrinsic factor doesn't get absorbed it will get eliminated. But in order for the receptor protein on the enterocyte to identify the B12, the intrinsic factor has to be bound to the B12. So the enterocyte then absorbs B12, and then B12 gets absorbed into our bloodstream. And in the blood, B12 is transported by this nice transport protein called trans, like for transport, cobalamin, too, like transport cobalamin, right? Cobalamin meaning B12. So that's why we say it's complex. There's a lot of different components that are required for proper B12 digestion, absorption, and transportation. But let me say one last thing here. So that means there are various causes for a B12 deficiency beyond just not eating enough B12. So there are lots of different reasons for why a person might become B12 deficient. So it's really important to check on each of these various stages and make sure that the person's body is, in fact, producing enough intrinsic factor, producing enough hydrochloric acid, producing the R binder protein, and making enough pancreatic enzymes to break down the R binder protein. Okie doke. So food sources, as we said, here's beef down here. Again, foods that might be fortified. Nutritional yeast isn't shown here. But as we said, the RDA is relatively low. It's a little more than 2 micrograms per day. And we said back here that our liver can store 3 milligrams. So it's about 1,000 times the RDA. So we can have a pretty good storage supply of B12 for a while. So again, deficiency can kind of creep up on us with B12. It wouldn't be so sudden. So that's why it's, again, an important thing to keep an eye on so that somebody could notice when their supply is decreasing, then you can identify either they're not eating enough or they're not absorbing it correctly. Alrighty, and then we're kind of backtracking numerically a little bit here. We're going to talk about B5, also known as pantothenic acid. Pantothenic acid can be metabolized to make 2 different coenzymes. So again, coenzyme A and acyl carrier protein. So remember, coenzyme A is that little component that gets added to the 2 little the little carbon-carbon chains when we make acetyl-CoA. So that's important for all sorts of metabolism. Also, acyl carrier protein supports fatty acid metabolism specifically. Other things that pantothenic acid supports is building or making cholesterol, making steroids then, and detoxifying many of our drugs. Food sources, again, chicken, beef, egg, some mushrooms can be a good source of B5, potatoes, some grains, tomatoes. Right now, we don't know of severe issues with too much pantothenic acid intake. And again, deficiencies with this one are relatively rare because it is pretty abundant across a good variety of foods. So in this case, we're not going to take a look at the pantothenic acid backbone, but you can kind of actually start to recognize that it's basically here, right? That's what is the same about these 2 molecules. And then up top, this is coenzyme A, so adding this CoA part. And this one down here is an acyl carrier protein by adding this component. And then food sources of pantothenic acid. So again, whole grains, especially fortified whole grains. As we said, mushrooms, like 1 cup of white mushrooms could be a decent source for the day. Sunflower seeds, peas, sweet potato, and then as we said, some meat and dairy products can also be a source. So again, pantothenic acid is available in a pretty good variety of foods, which is part of why it's not common to see a deficiency of pantothenic acid. Okay, and then now we're going to, Not quite yet. So biotin, biotin is this interesting molecule that, as I said earlier, it's kind of an honorary B vitamin. It's more newly discovered than the other B vitamins that we've talked about so far, but it gets categorized or classified with the B vitamins because it has many similar functions to the B vitamins we've discussed thus far. So biotin also supports or becomes part of different coenzyme systems used primarily in metabolism. So fatty acid synthesis, gluconeogenesis, and then metabolizing our 3 macronutrients. As I said, a relatively newly discovered nutrient, so the content in various foods is not well known yet. Deficiency with biotin, we do see this in 2 cases. Anyone consuming raw egg whites, large amounts of raw egg whites on a routine basis. Apparently there's a type of protein in raw egg whites that binds biotin and makes it unavailable. And then anyone getting intravenous food that isn't supplemented with biotin on a prolonged basis, several months on intravenous nutrition, if there's no biotin in that intravenous food. And then choline, another sort of honorary B vitamin or vitamin-like substance. Choline is interesting, and we've actually talked a little bit about choline already. I think in particular we mentioned phosphatidylcholine when we talked about the different types of lipids. We said that phosphatidylcholine is a component of bile. I don't think we said that phosphatidylcholine is part of lipoproteins or part of cell membranes, but it is. So we see phosphatidylcholine and another choline derivative called acetylcholine supporting many different functions in the body. So phosphatidylcholine, you see that primarily associated with phospholipids, right? So remember, phospholipids are part of the phospholipid bilayer of our cell membranes. Lipoproteins are phospholipids, and bile is also composed of phospholipids. And phosphatidylcholine is a type of phospholipid in the bile. And then acetylcholine functions to support neurotransmitter communication, basically, in the parasympathetic nervous system. So acetylcholine or acetylcholine supports, again, parasympathetic nervous system actions like contraction of the smooth muscles, like your digestive system, dilation of the blood vessels, allowing better blood flow, slowing the heart rate, and increasing secretions. Again, things that would support digestion or those processes of rest and digest. That's what parasympathetic nervous system is. Choline can also support homocysteine metabolism. Deficiency is relatively rare because choline is pretty abundant in our food supply. In the case that someone does become deficient, though, one of the things that we would see, one of the symptoms would be fat accumulation in the liver. And part of that would be due to this lack of ability to make phosphatidylcholine, which is what allows us to metabolize and transport fat and cholesterol. Again, toxicity, we're only going to see from over-supplementation of choline. And then again, you don't need to memorize the structure, but I just thought it'd be fun to take a look at choline. Here's your choline backbone. Here's acetylcholine, so not really a much larger structure, just adding a couple carbons and oxygens. And then phosphatidylcholine at the bottom. So you can see that is a pretty complex. Right, here's kind of your choline backbone, and here's phosphatidylcholine. Okay, so far we've just talked about vitamins that support metabolic processes, as well as some other things like homocysteine metabolism, red blood cell production, neurotransmitter production. So now we'll talk about some of the minerals that support metabolic pathways. So first one we'll mention is iodine. So iodine is an important component of the hormones that our thyroid gland makes. So the thyroid hormones play a role in body temperature regulation, and they actually kind of regulate all of these metabolic processes that we've just been talking about. So that means that iodine becomes really important for growth and reproduction, as well as overall metabolism. Iodine is not widely abundant in our food. It's widely abundant in saltwater foods, so fish and shellfish that we're going to find from the sea or the ocean, not freshwater or lakes. This is why salt, especially in the United States, is commonly iodized, because most of the United States is pretty landlocked, and so access to saltwater foods is low. So iodized salt can be a source of iodine. And then seaweed also can be a good source of iodine. Again, seaweed coming from saltwater oceans. We're going to take a look at excess iodine intake and iodine deficiency, and we're going to see that both of them are going to interfere with thyroid functioning. We'll also take a look at goiter, which is what we call the thyroid gland when it becomes enlarged. And we're going to see that both, again, toxicity of iodine, so overconsumption of iodine, and deficiency of iodine both can lead to goiter. Here's a quick look at the thyroid hormones and the fact that they contain iodine, right? You see all these little iodines. So this is thyroxine, otherwise known as T4. The second one is showing triiodothyronine, so T3, meaning triiodo, right? 3 iodines. And then at the bottom is tyrosine. So again, kind of an amino acid backbone to these thyroid hormones. Here's the picture of goiter. So the thyroid gland is kind of that little butterfly-shaped gland in the base of the neck. So this is just showing an enlarged thyroid due either to too much iodine or too little iodine. Let's talk first about what happens when we have too little iodine. A few different things here. So collectively, we could call all these iodine deficiency disorders, or IDDs. Again, body systems that will be affected here would be growth and development, neurological, hearing, fertility especially. We could potentially see congenital abnormalities as well as prenatal and infant death. So here specifically is looking at what happens when a pregnant person is iodine deficient. So the pregnant person themselves may experience some of these IDD deficiencies, but really the biggest concern with iodine deficiency during pregnancy is for the newborn or for the infant or the fetus. If the infant is born, they are at a much greater risk for cretinism, which is basically characterized by mental retardation, as well as stunted physical growth, and potentially deafness and muteness. So again, kind of specifically neurological and again, growth and developmental issues. For an adult or even for children or adolescents, hypothyroidism, meaning low thyroid hormones, low thyroid hormone levels. So this would happen if there was not enough iodine to make the thyroid hormones. Symptoms are going to be lower body temperature. Everything's going to be kind of like hypo here, right? So lower body temperature, more intolerance to cold, potentially see weight gain, and that's in part because of fatigue and sluggishness. So that's the one sort of not hypo, I guess, but hopefully that makes sense. If the metabolism, basically metabolic functioning overall, is kind of slowing down with hypothyroidism, so you'd see that could pretty straightforwardly lead to gaining weight. And then on the flip side, what happens if we have too much iodine? So too much iodine can actually interfere with the synthesis of thyroid hormones, ultimately. So kind of in the early stages, we would have hyperthyroidism, meaning we have really high levels of thyroid hormones. And this also goes by the name Graves' disease. So in hyperthyroidism, we see hypermetabolism, right? So we see increased heat production, We see muscle tremors. We see a lot of nervousness, like kind of like a super high heart rate, super high heartbeat. The eyes might even protrude a little bit, like starting to kind of pop out. And then, of course, with all this increased metabolism, metabolic activity, there's a greater likelihood of weight loss and hyperthyroidism. Alrighty, and then chromium. So chromium, definitely, I think, good to associate chromium with insulin. So a lot of folks who are diabetic or even pre-diabetic, a small chromium supplement can be helpful because chromium supports insulin production. Remember, insulin's job is to tell cells to take glucose up from the blood. Chromium also supports RNA and DNA metabolism, supports our immune system and overall growth. Whether or not folks are getting enough chromium, again, this is maybe a newer micronutrient to us, so we don't have a ton of information about whether or not intake is adequate in the US. So far, it seems to be that chromium is pretty widely available in our food. So deficiency, again, is relatively rare. What we know about chromium deficiency so far is just based on basically lab animals, mice and rats who've been kind of forced into chromium deficiency. And what we find is that glucose uptake from the blood is impaired and in some cases even inhibited. So this can lead to high blood glucose levels, which would then result in excessively high insulin levels. Again, most likely toxicity with high supplementation of chromium. Yeah, so beware of that. And then we have manganese. So manganese acts as a cofactor, again, in the metabolism of our macronutrients. Remember, cofactor is different from coenzyme. We said that coenzymes are molecules that support enzyme functioning, whereas cofactors are typically minerals. So that's why manganese is a cofactor supporting metabolism. Also supports cholesterol synthesis and urea formation when we are metabolizing the amine part of the amino acids. Manganese is also important for one of our antioxidant systems known as superoxide dismutase. Manganese is abundant in our whole grain foods. And again, toxicity can come about from oversupplementation. We're going to see the nervous system being affected primarily, resulting in spasms and tremors. Many of our fruits are also good sources of manganese. So you'll see it can be pretty easy to meet the RDA for manganese without really trying. And I think this is the last one for chapter 8, sulfur. Sulfur, I think, is one of my favorite minerals. We find sulfur, remember we said that some of the amino acids have these disulfide bridges that help make the shape of the, not the amino acids, but the peptide chains. So the chains of amino acids sometimes have these sulfur bridges, these disulfide bridges that help make the shape of the protein. So we see sulfur in a lot of our amino acids, and then we also see, methionine and cysteine are 2 examples. And then thiamine, vitamin B1, and biotin also contain sulfur. Remember that vitamins are large molecules made up of individual atoms, right? Individual elements. So sulfur is an element, manganese is an element, chromium is an element. These are all minerals. Iodine is an element. So it's not too crazy that we can see these elements in some of these other molecules or vitamins that we consume and use. So sulfur supports alcohol detoxification as well as many detoxification pathways, and outside the scope of this class, but very cool. Sulfur can support acid-base balance in the blood, of course, and that's in part because of its content in many different amino acids, which make up proteins. Right now, we don't have a ton of information about sulfur to indicate symptoms or issues associated with toxicity or deficiency. But again, sulfur toxicity is likely to only come about from excessive supplementation with sulfur. Okey-doke, and then this is kind of like an overview slide. So there are some questions in the chapter review that are answered on this slide. So what happens if we don't have enough B vitamin intake across the board? And this is an important question to ask, especially these days, because diets across the United States are not overly healthful, and B vitamins are some of the most lacking micronutrients across the common diets in the United States. So what happens if we don't get enough B vitamin? Primarily, we're going to see reduced work capacity, and that's like physical work. So as we've been discussing, B vitamins support metabolism. Metabolism is our way of deriving energy from our macronutrients. So if we aren't able to derive energy from macronutrients, we're not going to have a lot of energy to do work. So we're going to see poor work performance, meaning lower intensity of work and lower endurance, lower ability to like go for long periods of time. Diets that are high in unenriched, unfortified processed foods. This is like fast food. So fast food diets, junk food diets do not provide enough B vitamins. And again, many of our grain foods in whole grain form are rich sources of B vitamins. But when grains are so heavily processed, many of the B vitamins are lost. And if they're not replaced in the enrichment process, then those foods are going to be very low in B vitamins, so leading to reduced work capacity. Alrighty, and then these are just your review questions, so feel free to mute me and go through these and review at your own pace. As always, please email me with any questions, and we will see you next time for Chapter 9.